look at how to find critical numbers for functions. Critical numbers occur where the derivative f prime of x is equal to 0 or undefined. There are three main steps to finding critical numbers. The first step is to take the derivative. After taking the derivative, you want to look for where the derivative is undefined, and then you want to substitute in 0 for f prime of x, then solve for x. So let's start with that first step. Let's find the derivative of f of x is equal to x cubed plus 6x squared minus 15x. This is a polynomial function, so we can just use the power rule. The derivative of x cubed is 3x squared. The derivative of 6x squared is 12x. And the derivative of negative 15x gives us that minus 15. I like to look for where my derivative is undefined before I look for where it's equal to 0. That's just my personal preference. So the domain of 3x squared plus 12x minus 15 is all real numbers since it's a polynomial. So there actually isn't anywhere where this derivative is undefined. Next, we'll substitute in 0 for f prime of x, and then solve for x. Each term in this polynomial is divisible by 3, so we can factor out a 3. So we have 3 times the quantity of x squared plus 4x minus 5. We can then factor the x squared plus 4x minus 5. So we get 3 times the quantity of our first factor could be x plus 5. And then the next factor would be x minus 1. Then we can use the zero product property in order to solve for x. So we have x is equal to, x plus 5 is equal to 0 when x is equal to negative 5. And x minus 1 is equal to 0 when x is equal to positive 1. So our critical numbers are negative 5 and positive 1, since there's no x values where our derivative is undefined, and our derivative is equal to 0 when x is equal to negative 5 and 1. Let's take a look at this next function. Sorry that it's probably just going to keep doing that. So we have f of theta is equal to 4 theta minus tangent theta. First step is to take the derivative. So we have that f prime of theta is equal to the derivative of 4 theta is 4, and the derivative of tangent theta is secant squared theta. Let's check where this derivative is undefined. So f prime of theta is undefined when that secant squared theta, so when that secant theta is undefined. Secant theta is the same thing as 1 over cosine theta. And 1 over cosine theta is undefined when cosine theta is equal to 0. That occurs when theta is equal to pi over 2, or when it's equal to negative pi over 2, or you can think of it as 3 pi over 2. But then because we're going to keep going around that unit circle, each time we move pi more around our unit circle, we're going to end up with cosine equal to 0. So our derivative is undefined when theta is equal to pi over 2 plus pi over n. Now let's look at where our derivative is equal to 0. So when 0 is equal to 4 minus secant squared theta. So we need to solve for theta. I think it's a little easier to add secant squared theta to both sides. So we have secant squared theta is equal to 4. Then we need to take the square root of both sides. So we have secant theta is equal to positive or negative 2. Make sure you have that plus or minus there. If it doesn't jump out at you what the values of theta need to be, you can rewrite this. So we have 1 over cosine theta is equal to that plus or minus 2. Then taking the reciprocal, we have that cosine theta is equal to positive or negative 1/2. If we're looking at a super sketchy unit circle here, that will occur at pi over 3, at 2 pi over 3, and then each time we add pi to the pi over 3, or add pi to the 2 pi over 3. So theta will be equal to pi over 3 plus pi n, or 2 pi over 3 plus pi n. So altogether, our critical numbers, so where f prime of x is undefined, so that's theta is equal to pi over 2 plus pi n. Also, where our derivative is equal to 0, so pi over 3 plus pi n, and 2 pi over 3 plus pi n. There's a couple other ways that you could write this as well. These could probably be combined together. But here are our critical numbers for this function.